Hello, welcome to the New Stack Makers, a podcast where we talk about at-scale application development, deployment, and management. This episode of the New Stack Makers is sponsored by KubeCon CloudNativeCon. KubeCon CloudNativeCon conferences gather adopters and technologists to further the education and advancement of cloud-native computing. The vendor-neutral events feature domain experts and key maintainers behind popular projects such as Kubernetes, Prometheus, gRPC, Envoy, and more. The KubeCon Seattle event is coming right up, December 10th through 13th. It is sold out. You can still get on the waiting list. Registration will open soon for their 2019 events. Be sure to register early for KubeCon Barcelona, May 20th through 23rd. KubeCon Shanghai, June 24th through 26th, and KubeCon San Diego, November 18th through 21. Hope to see you there. Hey, it's Alex Williams of the New Stack here at KubeCon CloudNativeCon in China in Shanghai. And I'm here with Vicki Cheung, Engineering Manager at Lyft. Hi, Vicki.
Hi.
Vicki, tell us about how you started getting involved in infrastructure software. It's not exactly like, it's not exactly the most popular field at times, but it's some of the most complicated and the most interesting. How did you get into this world?
I pretty much stumbled into it. I've always joined companies when they're super small, like less than 5 people. So I just always literally did everything engineering-wise. So my first gig was at Duolingo, and I joined when it was like 3 people. So I started as like a new grad. I worked on like full stack stuff, and I worked on like the web app, the mobile app, and then eventually like further back the stack into like the API layer, and then into like venturing into infrastructure. And then a few years ago was when I really got into the weeds, when I joined OpenAI as the first employee after our CTO. And so without like anybody else in engineering, like literally the first thing we needed was infrastructure. And so that's when I just like built our entire like research infrastructure at OpenAI that was Kubernetes based. And then I did that for 2 years, and then earlier this year I joined Lyft, and I guess that's when I decided I'm in it now, like I'm super deep into it, so I'm decided to manage infrastructure at Lyft. So. Wow. So I'm curious about your education in programming languages, because I expect at Lyft, are you using Go for your service for your service mesh, for example? So in infrastructure, we definitely use Go quite a bit, especially because of our we're deeply integrated with a bunch of different open source projects that are like in the Kubernetes ecosystem and beyond. And a lot of those these days are Go based. So we've definitely made the switch to like start integrating more and more Go into our stack. In Lyft in general, we're pretty much like a Go and Python shop. We do have we're microservices, so like people can choose whatever they want, but those are kind of the preferred languages. So for me, I would say that like historically, just like the companies I've worked at have always been like Go or Python. So. Yeah. So those are that makes sense too, especially when you're talking about data management. And what I really wanted to talk about was Envoy and Service Mesh. Yeah. So you're the engineering manager at Lyft. Tell us a little bit about your job, and tell us a little bit about your work that you're doing, and then we can get into maybe the Envoy and Service Mesh aspect of it. Sure. Yeah. So my team is essentially the compute platform at Lyft, and so what I've been doing since I joined essentially is trying to move all of Lyft to Kubernetes. And so I guess like my role in that is I coordinate our migration to Kubernetes as like a company. And so we
earlier this year, we switched almost all of our machine learning and batch-based jobs to Kubernetes, and now we're in the process of moving like production Lyft to the platform.
Okay, so the obvious question is why Kubernetes? Like, what was the impetus for the shift?
Yeah, so it's kind of an interesting story behind it because Lyft actually tried to make the switch to like container-based stack maybe 2 or 3 years ago, back when like it was really, the hype was building up and everyone was trying to like make the switch, but like before Kubernetes was a thing. And so before that, we had our kind of homegrown like provisioning system that was salt-based, and we wanted to make everything container-based. So we again built some orchestration system in-house, and then Kubernetes came along, and then our engineering team was like, oh, actually, that looks a lot better because then we get the open source community support. And then we don't have to maintain our own thing. So then we kind of decided to wait for Kubernetes to mature a little bit, and then we are making the switch now.
So you are using Salt.
Yeah. So whatever is not migrated to Kubernetes currently is using Salt.
And what's the advantage of containers over Salt then?
So there's a few things. One is we really wanted to so Lyft, the way that we're structured is we're super microservice, micro-oriented. So we have literally hundreds of microservices. And then to allow people to have that freedom to pick their stack, I think containers is a natural option, so that they have control over their whole stack from kind of the VM layer. And then we as an infrastructure team now don't need to get into the weeds of how the service is going to be run. We just need to provide the platform that can run these images. And so that, I think the reason why we picked, I guess maybe I'll talk about containers first. Why we picked containers is then the contract between infrastructure and service owners is a lot clearer. We just say, okay, there's this platform that will run this very specific interface, and you just have to provide that. And then we picked Kubernetes because we looked at a bunch of different platforms for running containers, and we decided that Kubernetes was, the most supported, I think, in the ecosystem currently, and also because it was easily understood, I guess. There's less overhead in terms of operating it.
You described Lyft as a really collection of microservices. How is that embodied in the experience that the actual user has? How do you then take that technology that you're developing as microservices and make it something that people can really understand and use on their app all day in and day out? I guess what I'm trying to get at is how is Kubernetes helping with that experience that the user, that the actual customer has when they're using the application, and how has it helped in comparison to when you were using, your traditional stack that you're using before?
Yeah, I think one thing that's, maybe as a customer you might not see it directly, but it enables us to really improve developer productivity, and so we can bring new features to our customers a lot faster. And that's because now our engineers don't need to go and mangle with the salt, or they don't need to go and understand layers of infrastructure that they're not trained to understand or they're not supposed to understand. Now they just need to know that they can build an image that needs to run, and once they have that, they hand it over to the infrastructure team, and then that's it. And so I think the iteration's a lot faster that way. And I think secondly, the reason why we picked a completely open source stack was so that our engineers are empowered to learn about it if they want to, and then they can build whatever crazy prototype they want to based on Kubernetes, rather than go into some homegrown repo and it's okay, how do I make this one feature happen that wasn't originally supported? And so like all these things really matter in terms of like enabling our engineering team to do their best work.
Yeah, I can't imagine Lyft like, using homegrown repos.
Yeah, yeah, it's pretty painful. So yeah, I'll talk about this a little bit in my talk tomorrow as well, but we have like homegrown tooling to interact with like CLI tools that interact with our infrastructure. And you know, like all homegrown tools, it's not perfectly documented. So there are all these flags, like there's maybe like 20 flags that people can use. And then people come into Slack and they're like, hey, how do I do this one thing? And then our engineering team is like, oh, you just need to like give this one flag, obviously. But like, you know, we can like cut down on those interactions when they can just Google it. So
Yeah. That makes it easier. So, you know, as Lyft is like this like collection of microservices, that makes then like the idea of a service mesh really quite pertinent, doesn't it?
Yeah, I think that's why, like, Envoy gives us a lot of out-of-the-box support.
And perhaps you could just, for people who may not be familiar with Envoy, can you explain what it is?
Yeah, so Envoy is a service mesh. So as an application developer, let's say you interact with a bunch of other microservices, you don't need to necessarily configure each like service discovery like individually. You can just like be in the Envoy service mesh like network, and then you use the Envoy client to talk to the other services, and Envoy itself can figure out how to route the requests and how to structure them, and then it passes to the other service that you're talking to on the other end. And then they again like don't need to know necessarily like, you know, how they're going to interface with your service, because Envoy takes care of that. So Envoy abstracts away kind of all the networking and routing, and you just figure out like what service you need to talk to like by name, essentially.
So what's the biggest issue that you face then, you know, with a service mesh? What is it that you need to really be thinking about monitoring? What is it that you're managing in that environment that becomes really kind of critical, especially with an operation like Lyft that has such scale and dimension?
Yeah, I think then the challenge to us is to actually, I think, provide a coherent service to the service owners, right? Once you like start abstracting stuff away, then you need to enable your engineers to like somehow be able to do like things that they used to be able to do on their own. And so this is like both kind of like a pro and a con, right? Like now we have like centralized like this piece of infrastructure that like we can manage, but it's a con in that like now your engineer is completely bought into this, and so like you need to somehow provide a good experience for them. I don't know if this answers your question, but like one example is like, you know, we can do distributed tracing out of the box. Like as soon as you spin up a service on Lyft and you like start communicating on the service mesh, you get distributed tracing for free. And that's because like that's all the hooks are already in Envoy, and so like you as an application developer don't need to change a line of code to like make that happen. And that goes for like a lot of different like monitoring solutions, like all the monitoring your service health, for example, like how many 500s are you throwing on a request level? Like all of those things appear for free in all of our dashboards and monitoring and stuff. Like once you spin up a service, you get an Envoy dashboard for free, because like Envoy is able to collect all those stats and just, you know, have a centralized pipeline for throwing it out.
And so how's that translating into the developer experience?
So I think for the developer experience, like there's one central endpoint that they just need to know. They don't need to learn about like a bunch of different tooling. Like I have this monitoring solution and I have this tracing solution, and then I need to worry about like how to route my requests. Like that's all in one place. And so when you as an engineer onboard to our Lyft infrastructure, we just teach you how to use Envoy, and then that's it. Like you learn to get how to use all these tooling.
So then what is the role then of Istio? Do you know, and maybe you could explain Istio to people who are not familiar with it.
Yeah, so Istio is Envoy plus some more. It uses Envoy, but then it also manages your deployment. It comes with like a lot of the monitoring stuff for free. And I think it's great because, you know, whereas at Lyft we started kind of the other way around, we'd always used Envoy. So we built in a lot of these like monitoring and deployments and stuff like into our like in-house infrastructure. These are things that people, if they just adopted Envoy out of the box, they would probably have to build and integrate. Istio gives you that kind of bootstrapped. So, like I said, we started the other way around. So we don't use Istio because we'd always had the stack.
You always had Envoy.
Yeah, but if you like started something from scratch today, then it probably makes a lot of sense for you to use Istio instead of like raw Envoy.
How come?
Well, I think like if you need the kind of like all the surrounding tooling that like Istio already has built, and you kind of like fit into that model, I think it's just a lot easier to like use that. For us, it like didn't really make sense. So.
It's like double work almost to actually implement it, wouldn't it?
Right, because then we have to like migrate everyone to that model while we already have something working.
Or I have something working on as is. So what is that then? What's the next iteration for Lyft with Envoy? What is that next step you're looking to take with it?
Yeah, a lot of the work that's going into it these days is actually making our Kubernetes integration work seamlessly. So the way we've structured it is we have several production clusters, and normally you would have like a virtual network per cluster, so you might have like an overlay network or something. But because we already have production traffic flowing through our legacy stack, we wanted to kind of ramp up the migration as opposed to like, okay, let's take this piece and drop it into Kubernetes and route it that way like 100%. We wanted to like slowly have this like gradual ramp up and also like not surprise our engineers suddenly. And so in order to do that, we actually have one single Envoy mesh across all our clusters and our legacy stack. So like if you're familiar with Kubernetes, like now your pods normally would have this like cluster IP that is routable within the cluster, but not necessarily, say, in your larger VPC network. We've made our own CNI networking stack so that like the pod actually has a first-class IP and it registers that with the mesh network. So now a pod appears as if it's just another EC2 instance, and our Envoy mesh network just routes to pods and like between pods and legacy stack kind of seamlessly. And then so some of the work is going into that and also kind of optimizing that, I guess, to make sure that, maybe we want to optimize for putting requests like under certain clusters so they don't cross like AZ boundaries, or maybe we want to do like blue-green deployments and see like how we want to switch traffic over, stuff like that.
What are some of the other tools you're using then, or you're starting to use that, come from the open source community?
Yeah, so we use Prometheus heavily. This is a stack that didn't exist in our legacy stack, so we had our own observability pipeline. Now that we're bought into all of these open source projects and they all have Prometheus kind of built in, so we started switching a lot of our observability stack over. We also use actually a bunch of open source projects too. So we use Heptio auth very heavily. We use KIM for like doing...
Which one?
KIM for doing IAM authentication. Let's see. We also use like the Kubernetes device mapper for all our GPU needs. Yeah, the list goes on. There's actually quite a collection of projects that's required to actually provide feature parity between our new clusters and our legacy stack.
But you talked about the observability stack. I'm curious about that. What is the observability stack?
Yeah, I guess maybe this is also kind of interesting is because the way we want to do our migration is that, we have hundreds of services to migrate. We don't want to like have to actually change anything in the service to make it adapt to the new stack. So we're making our Kubernetes stack look kind of as similar as possible to the old stack. And that means that like a lot of like observability and networking, all that stuff will be provided out of the box, and like the application developer only provides the container image. And so we use the Kubernetes sidecars very heavily. So if you deploy a new deployment on our cluster, we automatically use an emission controller to like inject all these sidecars. And so you get like a logging sidecar for free, and then like the Envoy sidecar and so on.
So those help with the sidecars and play what role then?
So the sidecars, for example, we have the Envoy sidecar, so that mimics like what used to be the Envoy process in our like EC2 instances world. And then we have the logging sidecar that like slurps all the logs. I guess we also provide a statsd sidecar so that, you know, our old like analytics pipeline and like metrics pipeline can continue to flow. So we don't have to like just straight up switch to Prometheus.
So where are you in that migration then? Are you how far along are you? Or is this a never-ending kind of story?
Hopefully not never-ending. Yeah, I know migrations always kind of take longer than you expect because you've spent so many years refining your old stack, right? And now you need to make sure that your new stack is at least just as good. So yeah, that takes a long time to even just like bootstrap it to that level. But we're kind of in, I would call it like phase one, where maybe right now when you request like a Lyft ride, like a tiny portion of that goes through our Kubernetes stack. And our goal is like maybe sometime next year, most of it will go through our Kubernetes stack.
So in terms of the architecture, I mean, the underlying infrastructure, what is Lyft built on? Are you using multiple cloud services? Are you using AWS? What is that infrastructure you're relying upon underneath?
Yeah, we're mostly an AWS shop.
Right. Does the multi-cloud mean anything to you? Does it have any kind of meaning at all in terms of what you're thinking through and everything?
I think it's attractive to think about, like, if you can decouple yourself from maybe like, any kind of single failure would be, good from a resilience standpoint. I think Kubernetes enables that. We have been mostly focused on our AWS efforts, but that's something that we know that in the future, if we needed that, like, we're able to do that with Kubernetes.
Well, Vicki, thank you so much for taking some time to talk today, speaking over the loudspeakers here and waiting for the noise to dull a little bit. Appreciate your patience, and thank you so much. It's so fascinating to hear the story about Lyft. I'm a loyal user of Lyft, and I just love the service, and it's good to know that there's all this engineering exploration going on so I can see new features, I guess. So.
Yeah, well, thank you.
Yeah, thank you very much.
This episode of the New Stack Makers is sponsored by KubeCon CloudNativeCon. KubeCon CloudNativeCon conferences gather adopters and technologists to further the education and advancement of cloud-native computing. The vendor-neutral events feature domain experts and key maintainers behind popular projects such as Kubernetes, Prometheus, gRPC, Envoy, and more. The KubeCon Seattle event is coming right up, December 10th through 13th. It is sold out. You can still get on the waiting list. Registration will open soon for their 2019 events. Be sure to register early for KubeCon Barcelona, May 20th through 23rd. KubeCon Shanghai, June 24th through 26th, and KubeCon San Diego, November 18th through 21. Hope to see you there. Listen to more episodes of the New Stack Makers at thenewstack.io/podcasts. Please rate and review us on iTunes, like us on YouTube, and follow us on SoundCloud. Thanks for listening, and see you next time.